All right, our job here is to find all the wholes of this function. This time we have a little bit more denominator factoring to happen. We have a GCF down there. And so I'm going to recognize they all have a 3 in common and work to factor it out so that I can identify my points of discontinuity through the factor solve process. So I set a 3 out in front of a parentheses, divide each of these terms by 3. I should get x squared minus 7x plus 12. And then I go ahead and do the magic x with the denominator. To continue factoring, I put 12 up top because it's my c value. A value is 1, thankfully. That's nice. So 1 times 12 there on top. The bottom is negative 7. So I just figure out that 4 and 3 multiply to be 12 and add to be 7. If both of them are negative, that takes care of that negative on the 7. So this factors to be 3 times x minus 4 times x minus 3. Now I can take those two factors and set them each equal to 0 to identify my points of discontinuity are x equals 4 and 3. So if I plugged in 3 or 4, I would get problems. So my domain is the all real numbers except x can't be those two values, 4 and 3. So our job is to decipher what type of point of discontinuity those are by now factoring the numerator. So the numerator also factors using the magic x, 3 on top, 3 times the 1 is 3, and then negative 4. And then you figure out that 3 and 1 have to be your only product of 3 that adds to be negative 4 to make them negative to make it work. So these are your magic numbers that multiply to be positive 3, add to be negative 4. So I factor here and get x minus 3, x minus 1. And the reason why I factored the numerator is so that I can reduce the problem. And so I'm looking for this x minus 3 to cancel out with this x minus 3 on the bottom. Now, if you don't need to rewrite it, you can see that you can cancel it, but I'm going to rewrite it for clarity's sake. So we're going to rewrite this to be altogether one fraction, x minus 3 times x minus 1 over 3x minus 4 times x minus 3. Now I could have rearranged this to make it even better, but I'll leave the diagonal there. It's actually good practice where you can see that anything divided by itself, even if it's just a little bit slanted, anything divided by itself is 1. So these x minus 3's divide out. This function reduces to be x minus 1 over 3 times x minus 4. This is the reduced version of the function, and it would be what the graph represents, except that I have a point of discontinuity still at x equals 3. So my job is to pay attention to the fact that I reduced and a factor reduced out. That factor was the one that resulted in a point of discontinuity of 3. So 3 identifies as the whole. Now 4 is the vertical asymptote. That wasn't the question though. 3 is where the hole is. So I have a hole here because this x minus 3 produced the 3. It canceled out. So a hole at x equals 3. My job though is to determine what coordinate it's at. So you decide to plug in 3 to your reduced version of the function. So we take 3 and plug it in here. Not the original function, in the reduced version. In the original function, you should just get an undefined result. So we should get 3 minus 1 over 3 times 3 minus 4. And then you reduce that out. You should get 2 on the top. You should get a negative 1 on the bottom times 3 gives you a negative 3 y height result. So the hole is at the coordinate 3, negative 2/3.